All right. Hello, everyone. I'm Bernd, and this is day 24 of Advent of Code, the last full proper day. Today was about moving through a valley, and this valley is given by these dots, and we want to reach from one end to the other end. However, the problem is there's a few blizzards around, so blizzards are given an input by these arrows, and at each time step they move one position in the direction of the arrow, and if they reach one end, they just restart at the other end. And yeah, in each time step, we're allowed to either move one position or stay at the same position. And we want to reach the other end as quickly as possible while avoiding the positions with blizzards on them at each time step. All right, so how can we do that? So, of course, we need some code to make our lives a bit easier. So we need, for example, a position, which we can add with another position, and this just adds the x and the y coordinates. Then for each step representation, so there's all these four arrows, we need a corresponding step vector, which will be 1, 0, and so on. Then we want the class Blizzard. So Blizzard has a position, a current position, and as well as a direction. Then Blizzard can move. So Blizzard moves by updating the position by adding the current direction. But then we need to also implement the way that it resets if it's and one at the end of the valley, it restarts at the other end. So we just check if the x position is too small, we set the x position to the corresponding large value. If the x position is too large, we set it to the corresponding small value of the other end of the valley, and the same for the y position. And then, of course, we need to read the file and split it into lines. And then from this input, we want to get all the blizzards. So we have this big input, and we go through all the lines and for all the character in the lines. If the character is equal to this number sign, that's not part of the valley even, so we just continue. Otherwise, we add the corresponding position to the valley, and then only if it's a dot, we continue. Otherwise, there's a blizzard as this position. So the blizzard will be given by the position, and the direction will be given by this, using the step dictionary to get the character of this like arrow character and convert it into a position or a direction vector. Okay, with that, then we want to be able to do a round, so we start with a set of possible positions and set a list of blizzards, and as well as the valley, the positions of the valley, and then we want to update these possible positions. So first we update all the blizzards, so we just call this move method of each blizzard. And then we have the blizzard positions, will be a set of position for each blizzard, of their position for each blizzard. And then we know that the clear position is just all the positions in the valley without the blizzard positions. Another set of positions we need to calculate is the reachable positions. So it's each positions we're allowed to stay and wait for a minute. In this case, therefore we can have each position will be reachable. Each position in the possible reachable positions at the last time step will be reachable in the next time step. And then for each position, we are also allowed to do one step in any direction. So we iterate for all the positions and all the steps and add that to the reachable positions. And then the new possible positions will just be all positions which are both reachable as well as clear. So we just intersect those two sets, and this will give us the new possible positions. Okay, with that we can solve the problem. So of course we need to process our lines and get the blizzards, the valley positions, as well as width and height. And then at first we'll start with the set of possible positions, which will just include this position. This happens to be the position we start on. And then we just iterate and update the possible positions, as well as by first updating I call this do round function, first updating the blizzard positions, and then updating our possible positions. And then after updating, we check if for any position the y coordinate is equal to the height -1, which means we reach like all the way down where our goal position is, and we return the corresponding time step. Okay, for that we can do a little test. Let's see. And with a bit of luck, yes, that looks good. So that works out. For part 2 is very similar, but only we figure out we forgot something at the beginning. So we need to find the time to get to the other end, go back to the beginning, and then get to the other end again. For this we define a little function, reach a y of, and then we supply with a particular y coordinate from a starting position, and we need to take account of blizzards in the grid and update the blizzards as well. That's just what we had in the previous thing. We have a while loop, and we keep updating our possible positions. And if the y coordinate is the y we want, we return. So yeah, so first for the problem, then we parse the lines, and then we first want to reach the height of the y of height -1, which is the first goal position. And then we want to go back and reach a height of 0, which will be our second goal position. And then we want to go back to the end again and want to go until we reach a height of height -1. And the sum of these 3 rounds will be a solution. So we could again run a little test. And that looks good as well. So we can also run it on the proper input, and it takes a bit more than 10 seconds, so nothing dramatic. And yeah, that's it for day 24. Hope you enjoyed today's puzzle. Happy holidays, and see you around.